Greetings and welcome to Maths and Science Tutoring. In this section, in this video, we're going to work on question 3, Physical Science Paper 1, TBE 2022. This is the June 2022 past exam question. So we are going to focus on mechanics, vertical projectile motion. So the question reads as follows: a small disk C is thrown vertically upwards at a speed of 15 meters per second from the edge of the roof of a building of height 30 meters. After 0.5 seconds, a small ball B is shot vertically upwards from the foot of the building at a speed of 40 meters per second in order to hit disk C. Ignore the effects of air resistance. So the information is given here. Explain the term projectile. Okay. A projectile is any object that is moving in the air, and that object will be experiencing free fall when it is thrown or when it is shot or when it is dropped. So we can say, give it as a definition: a projectile is an object that is moving through the air. But this is the most important part. As it is moving through the air, it is experiencing free fall. Okay, it is experiencing free fall after being dropped. You can add that one, after being dropped, or after it's being thrown, or after it has been shot or shot. Okay, so a projectile is an object that is moving through the air experiencing free fall. Okay, free fall is an undisturbed movement of an object when only gravitational force is acting on it. Okay, let's write it here. It's not necessary to write it in the question. Okay, free fall is an unhindered, or you can say undisturbed motion of an object. Motion of an object when only gravitational force is acting on the object. Okay, so coming back to the definition of a projectile. So a projectile is simply an object that is in free fall. It means as it is moving, it is undisturbed. Okay, and the only force that is acting on it is gravitational force. So this is how you will present your answer to that part. Question 3.2 is to calculate the time taken by disk C to reach its maximum height. The time taken by disk C to reach its maximum height. Okay, so this is 3.2.1. Now, to calculate the time taken here, we need to analyze the data that is given. So when the disk C is thrown, okay, it was projected upward. It was projected upward. So as it moved up, there is a point where it had to stop instantly and then fall back. Okay, so at that point it reached a maximum velocity of a final velocity of 0. So what I will always encourage students is to, you can just present your information in the form of a table. This does not give you marks per se, but it just helps you to able to analyze your data, the data that is given with respect to the information that we are given here. Okay, just put a small table here. You can do it on a rough piece of paper. So we have got 5 variables that we need to analyze. The first one is the final velocity, then followed by the initial velocity, then we have got time, and then we have got g. We'll use g or acceleration, okay, because it is in a free fall, gravitational force is acting on it, and then we have got a delta x or delta y. So whenever you are studying questions on vertical projectile motion, most likely we will use equations of motion. So equations of motion is a combination of these 5 variables. It's all that you will most likely be asked: the final velocity, the initial velocity, the time taken, and the acceleration of the object, and the displacement. So put it in the form of a table like that, and then from the given information, the question is asking us based on disk C. Okay, so you must be careful there. We've got a disk C. So we are going to analyze the motion of the disk from the instant it was thrown, and then it says here that it reached a maximum height. So maximum height indicates the highest point that it reached before it started to fall back to the ground. So that maximum height, the term maximum height, refers to the fact that our final velocity is 0. So we are going to insert our v as 0 here. So we are given the final velocity from that statement, maximum height. Okay, we are also given the initial velocity, which is 15 meters per second. So 15 meters is our initial velocity. Okay, one other thing that I forgot to mention here is when you are dealing with these variables, all of them except the time, they are vector quantities. So you must consider the direction. Okay, you can take the upward force, the upward motion movement as your positive direction, which is what I am considering in this case. Okay, or you can take the downward force as your positive. So it's up to you, but you are advised to stick to one particular choice. So if you are going to assume that your taking upward is a positive direction, okay, so when you substitute your values, you must make sure that the directions must be indicated by the negatives and the positives. So here I've taken the initial velocity upward as 15 meters per second as positive, because I'm taking up as positive. So coming back to the information they were given, so we are given the initial velocity, which we have here, and then the question is asking us to calculate time. So time is the variable that we are going to calculate. So I would put a question mark here to say that this is what we are going to calculate. Okay, our A is the G, which is the acceleration, because our object is a projectile. The moment it is thrown, it becomes a projectile, which means the only force that is acting on it is gravitational force. So our gravitational acceleration is g. Now gravitational acceleration is always, it's a constant 9.8, but it acts downwards. So since we have taken up as positive, so our g is going to be negative 9.8 meters per second. So we are going to take it as negative 9.8 meters per second. Okay, and then now we are given the values, the displacement. We are not given how high it went from the initial position to the maximum position here. So displacement is not given. You can put it as a dash or an x, which means whatever equation that we are going to, equation of motion, we are going to choose an equation that does not have displacement. So as you are aware that we have got 4 equations, which are stated as V final is equal to V initial plus A delta T. Okay, the second one is V final squared is equal to V initial squared plus 2A delta X. The third one is delta X is equal to V initial delta T plus half A delta T squared. These equations, you'll find them on your formula sheet. Okay, the fourth one is delta X. Delta X again is equal to V final plus V initial over 2 half the sum of the initial and final multiplied by time. So here you will find that our choice of the equations of motion depends on what information we are given. Okay, as we have analyzed our information here, we don't have a delta x. We are not given delta x. In other words, the displacement from initial position, the point it was thrown, up to the maximum. We don't know how high it went up. So it means we are going to exclude all the equations that do not add displacement. So equation 2 will be out of the picture. Equation 3 will be out of the picture because we don't know the delta x. Equation 4 is also, we are not going to. So we are only going to use the first equation, V final is equal to V initial. So that is how it can help you to determine, to quickly pick which equation you can use. Okay. When you keep on practicing this, it becomes almost intuitive. You'll be able to quickly figure out what equation you can pick up. But at initial stage, when you are exercising, when you are practicing such problems, it's always helpful to put up your diagram like that one, your table, small table. There are no marks awarded for it, but it helps you to pick up the correct formula. Okay, so we are now going to use these equations that we have here. Okay, so therefore our final equation is going to be V final, okay, is equal to V initial plus A delta T. Okay, so our final velocity is 0 is equal to initial, we are given it's 15 plus A, that is negative 9.8, okay, by delta T. So take this one to the other side, negative 15 is equal to negative 9.8 delta T. So our delta T is going to be 15 divided by negative 1.8. Okay, negative 15 over negative 9.8. So our time is that. So let's work it out. So we have got a, okay, of course the negative will cancel. So just put the 15 over or divided by 9.8. Okay, that will give us 1.53. Okay, that is 1.53. So our time is 1.53 seconds. Remember, your time should always be positive. When you see your time a value that is negative, which means there might be something wrong in your calculation. So the time taken by disk C to reach the maximum is 1.53 seconds. Let's move on to question 3.3. So question 3.22. 3.22 is asking us to calculate the maximum height above the ground reached by disk C. The maximum height. The maximum height above the ground reached by disk C. So what we need to do to work out this one is our disk C was thrown up, okay, from a height of 30 meters. But it was thrown it from the edge of this roof. It went a further distance up. So first we need to calculate that. That distance is our displacement. Okay, so we need to calculate how high did it go up. So once we get that displacement, we are going to add to 30 meters. Okay, because the question is asking us to calculate the height above the ground. So our height, okay, our height is going to be 30 meters plus the displacement of C up to the maximum height. Okay, so that's what we'll do. So now we have analyzed the information here in our table. Delta X is now what we are going to calculate. Okay, so we can pick any equation that has got a delta X here. Okay, equations 2, 3, and 4, they will apply as well. So let's calculate delta X and delta X for C, then we'll add to 30 meters. So to be able to do that, we can choose any equation. I will choose equation 2, but any one of them is applicable. So we're going to have V final squared is equal to V initial squared plus 2A delta X. So we know our V final squared is 0 squared because it reached a maximum, and our initial velocity is 15, okay, squared plus 2. Our acceleration is gravitational acceleration, which is negative 9.8, it x downwards, times displacement delta X. Okay, so multiply that out. So this is 0, this is 225, 15 squared minus 2 by that one, negative 19.6 delta X. Okay, let me just come and put it here. So okay, I'll just continue here. This one over, that is negative 225 is equal to negative 19.6 delta X divided by negative 19 divided by negative 19. So our delta X is negative 225 over negative 19.6. Okay, which is going to give us, let's calculate that one, 225 over 19.6, that is 11.479. So that is going to give us 11.48. So this is 11.48 meters. Okay, in physical sciences, in physics, you you are requested to express your final answer to a minimum of 2 decimal places. So 2 decimal places is okay, or 3 decimal places and above. Okay. So therefore, let's come to our height now. So our height above the ground, so therefore our height is going to be 30 meters plus the 11.48 meters, so which is going to give us 41.48 meters. So that is the height above the ground. Okay. Coming to question 3.3. Okay. Question 3.3. Calculate the time from the moment that disk C was thrown upwards until the time the ball B hits the disk. Okay. Let's come back to this space here. All right. Right, so three point three is asking us to calculate the time from the moment that disk C was thrown upwards until the time ball B is the disk. So we have got ball B that was thrown from the ground. Okay, as it was thrown up, first of all, we are given some information here. Ball B was thrown 0.5 seconds, okay, after ball C had been thrown. So there are many options that we can take here, but I am going to take the ground as my reference point. Okay, if we take the ground as the reference point, so the ball B is going to be thrown. So from the initial velocity, from the initial position of ball B, we are going to consider the displacement of ball B. So let's call that a delta XB, okay, which is the displacement of ball B. Okay, at the instant where ball B knocks, or what is the question here? It hits the disk C. Okay, at that instant, we will realize that they are at the same height from the ground. Okay, so ball C and ball B will be at the same height for ball B to be able to hit ball C. So what we need to have is the displacement of ball B. I'm taking now the ground, okay, as my reference point. So when ball B increases its position upward, that is the displacement. That position should be equal to the displacement of ball C. Okay, the displacement of the disk C rather. So I am referring to ball C, to the ball C. So that is the disk C. Okay, so the disk C here, but when you look at the displacement of disk C is already at a height. So the displacement of disk C will be 30 meters plus its new displacement when it moves up. So we are going to say delta XB, the displacement of ball B, will be equal to the displacement of disk C. plus 30 meters, because it is 30 meters above the ground. Okay, so now the displacement of ball B, let's now use the displacement of ball B. The displacement of ball B, delta xb, if we write it in terms of our formulae, it is going to be vi delta t, okay, plus, actually it is going to be delta t minus 0,5. Okay, I will explain that one, plus a half a delta t minus 0,5. Now I'm assuming here that delta t is the time taken by a ball C. So if ball C, disk C took some time, which is delta t, which means ball B was thrown 0,5 seconds afterwards. So it means for it to hit disk C, it is going to take 0,5 seconds less. The time it is going to take is 0,5. So from the time delta t for C, we are going to subtract that. So this statement here will give us the displacement for a delta B. Actually, it's squared here. Okay, let's look at the delta C, the displacement of delta C. So the displacement of delta C will be VI, again we use the same one, VI delta T, which is our time taken by disk C, plus half a delta t squared. But we said that this we are going to add 30 meters because it is already 30 meters above the ground. So we are going to say plus 30. Okay, so now since we said that these two are going to be equal, so we equate the two. So we're going to have one equation which I can say that VI into delta t minus 0,5 plus half a, okay, half a delta t minus 0,5 squared. So this is the displacement of ball B as expressed here. This is equal to the displacement of ball C, because for ball B to hit disk C, they must be at the same height. So VI delta t plus half a delta t squared plus 30. Okay, so now let's put in some values here. So the initial velocity for ball B we are given is 40. So this is a 40 into delta t minus 0.5, okay, plus half a, the acceleration is the same, negative 9.8 into delta t minus 0.5, okay, squared. This should be equal to initial velocity for disk C is 15 meters. So that is 15 times the time it took plus half the acceleration, negative 9.8 times the time it took again, delta t squared plus 30. Okay, so the rest is just to multiply this out. So 40 there, that will give us 40 delta t minus 0.5 into 40, that is 20. Okay, this is negative 4.9, half of negative 9.9 into delta t minus 0.5 squared. This will give us delta t minus delta t squared, delta t, that is delta t plus 0.25, okay, squaring here, because what we have here is a delta t minus 0.5 squared, which is delta t like that, okay, minus 0.5. So square there, and then let's multiply further. This is going to give us on the right side 15 delta t, okay, minus 4.98 minus 4.9 delta t squared plus 30, okay. So let's multiply over here. So we will have 40 delta t minus 20, this in there, that is negative 4.9 delta t squared in there, that will give us a positive 9, 4.9 delta t, this multiplied by that one, let's work it out, 4.9 by 0.25, okay, 4.9 by 0.25. What do we have here? 1.225. So this will give us a negative 1.225, negative 1.225. This is equal to 15 delta t minus 4.9 delta t squared plus 30, okay. Something will cancel out here. I think there's a negative 4.9, there's a negative 4.9, we'll take it out. Then collecting like terms, so the 20 and the negative 1.225, take it to the right, this one over, so we are going eventually going to have 40 delta t, okay, plus 4.9 delta t minus 15 delta t, okay, so everything is gone there, will be equal to, there's a 30 here plus 20 and then plus 1.225. Okay, let's clear some space over here. Right, then continuing there, we now have 40 plus 4.9, okay, 40 plus 40 plus 4.9 negative that one. Let's put it in our calculators. Okay, so 40 plus 4.9, okay, minus 15, that will give us 229.9. So this is a 29.9 delta t will be equal to 30 plus 20, 50, that is 51.225. So that's 51.225 divided by 29.9 divided by 29.9. So that will give us delta t will be equal to 51.225 over 29.9 to give us the time. Okay, let's punch it in. 50 1.225 to 1.225, okay, 51.225 over 29.9, okay, that will give us answer 1.713. So that will be 1.71. So that will be 1.71 seconds. So which gives us the time that ball B took to hit disk C. Okay. So that is our final answer to that question. Then continuing to 3.4. On the same set of axes, sketch graphs of velocity versus time for disk C and the ball B from the moment that disk C was thrown upwards until ball B hits disk C. Label the graph for ball B as B and the graph for disk C as C. Clearly indicate, so we have to indicate the initial velocities of ball B and disk C, the time at which ball B was shot upward, the time at which disk C reaches its maximum height, the time at which ball B hits disk C. Okay. So now we are going to sketch here. Now to sketch, we are going to have, let's put in some lines here. We are going to have our vertical line to represent the vertical axis, okay? Right. So our velocity, this is a velocity time graph. As we are given, we are going to sketch a velocity versus time graph. So this is our vertical line, and we are going to have our time axis. Our time axis, put our time axis over here. Okay, so on this, and this is our 0. Okay, we know that velocity can be positive or negative, so this is the positive and that is the negative. And then this is our time t. Now we are required to indicate the initial velocity of ball B and the disk C. Now we also need to take into consideration our direction that we have mentioned. We said that we are going to take upward as our positive. So when we threw disk C upward, we started with a velocity of 15 meters per second. So we are going to put 15 meters somewhere here. So this is 15 meters per second. So we'll start it at the positive side of our velocity scale, okay, which is our y-axis here. So we'll start at 15 meters per second on the positive side. If you take downward as negative, your diagram will more likely be flipped over. So your 15 will be on the negative because we are going to consider 15 as a negative direction. And then from there, the ball is going to, now we are looking at the motion of disk C. Disk C is going to move up, but as it moves up, it's going to reach a distance, a velocity of 0. So from 50 meters, we assume that it is going to come down to 0 at its maximum height. So it will reduce from 15 to 0, but at the same time, the time scale will be in operation. So we are going to draw a line from 15 down to 0. Okay, so a line will draw from here, and then we put it to 0. But when it reaches the maximum point, it is also going to travel downward. So it will continue further down. Okay, it will continue further down from here. Okay, let's do that. So basically we are going to have a straight line that goes like that, okay, to that point. So the point at which it is going to cross the x-axis, that is where it reached the maximum point, the maximum height, and it did that in I'm not sure if I have rubbed the answer there. It was 1.53, if you still remember. Okay, it was 1.53 to reach the maximum height. So our time taken by ball B is 1.53 seconds. Okay, and then it was hit by ball B at a certain time there. We don't know the velocity. Now, so that is the trajectory, the velocity, time graph for C. So we can label it as C here. Now, ball B, it was projected, it was thrown up at a speed of 40 meters per second. We still have here, still remember. So, but now it was thrown at after 0.5. So after 0.5, let's put our 0.5 here, somewhere there at 0.5. It means 0.5 seconds after ball C had been, disc C had been thrown. So at that instant, ball B was thrown. So let's put some dotted lines there to indicate. But ball C was thrown at a velocity of 40. So somewhere there, let's put our 40 meters per second. Meters per second. So from there, we are going to draw our graph, okay, the motion of the ball B. So of course, when it was thrown up, the speed was reducing. Okay, so we'll draw another line from here, coming down to that, okay. Somewhere here, okay, we're going to stop there. At that instant, at that point, they are all at the same time scale. At that point, that's where it has got 1.71 seconds. Okay, we believe that the ball had to hit disc C when it was still traveling upward, so it didn't reach a maximum. So your line should be hanging above the time scale here. So it might be somewhere here. All right. So this will be our displacement for ball B. Okay, actually the velocity for ball B. So we have got two lines here, this one and that. These are just imaginary lines to indicate the time scale. So we have indicated the velocity of the ball B and the disc C, initial velocity. So yes, initial velocity for ball B and initial velocity for disc C. The time at which ball B was shot upward, yes, we have indicated there. It was shot 0.5 seconds into our time scale. And the time at which disc C reaches its maximum, so disc C reached its maximum after 1.53 seconds, so we've indicated that one. And the time at which ball B hits disc A, so ball B, it hit disc C, so disc C at that instant was moving downward after it reached maximum, so the time is 1.71. We've indicated that. So all the information is shown. So that diagram will represent our velocity time graph. Okay, So that brings us to the end of this section. Okay, watch some more videos. I've got more questions on vertical projectile motion. So subscribe, share, put your comments, and give your likes. Thank you for watching, and it's a goodbye. See you in our next section. Bye.